Good morning. Today we are going to see a topic in the subject discrete structure and optimization technique. My topic is northwest corner method. First we should know what is meant by a transportation problem. Transportation problem is a type of a linear programming problem. In this problem we are tasked with transporting goods from several sources to various destinations. Our main aim is to minimize the cost and maximize the profit. Transportation problem is further divided into two types: balanced transportation problem and unbalanced transportation problem. Balanced transportation problem means the supply and the demand values or should be equal. If it is not equal, then the transportation problem is said to be an unbalanced transportation problem. We cannot solve an unbalanced transportation problem, so we are going to convert unbalanced into balanced by adding a dummy row and column to our problem. Then our problem will become a balanced one and we can solve by using several methods. There are so many methods in transportation problem. My first method is northwest corner method. To find this, we are going to use the following step. Step 1 is we have to start our allocation to the northwest corner cell of the matrix. Assign the minimum value of the demand. That is, if the minimum value of a supply and the minimum value of the demand, we want to compare that. Which one is minimum? We have to take that minimum value alone. Subtract that minimum value from the corresponding row and column. This can result in the three possible scenarios. If the supply is 0, then cross out the row and move down the next cell. If the demand is 0, cross out the column and move right to the next cell. If both supply and demand are 0, cross out both row and column and move diagonally to the next cell. Repeat these steps until all the supply and demand values are 0. Our first problem is get an initial basic feasible solution. Whatever the solution we are having is said to be an initial basic feasible solution for this problem by using northwest corner rule. Here our total supply is 950 and our total demand is 950. That is, in our right corner we are having a supply. If we add 250 plus 300 plus 400, we will get the value as 950. Similarly, if we add the demand value, we will get as 950. Hence our problem is balanced. Now we are going to use a northwest corner step 1. Our step 1 is choose our northwest value. Here our northwest value is 11. In supply we are having the value as 250, in demand we are having our value as 200. So we have to choose our demand value as 200, cross out our column, that is D1 will be crossed out, and we want to subtract our supply value 250 from 200. If we subtract it, we will get the value as 50. So my problem will become 11,200. My allocation is 11,200. In supply 250 will reduce to 50. In demand 200 is reduced to 0. My second northwest corner has the value as 13. While comparing this supply and demand, my supply is very minimum when compared to my demand. So 50. I am going to cross out the row and I am going to subtract the 225 from 50. We will get the value as 175. In table 2, it is observed that row is crossed out, the column is balanced, that is 175. Next 18 is my northwest corner number, so I am going to allocate my number as 18. Here 175 and 300, the minimum value is 175, so I am going to allocate my 175 in the northwest corner and I am subtracting that 175 to my 300. I will get the value as 125. Finally, I am having 14, 10, 13, 10. So if I allocate 14 as 125, the both row and column are having 125 and 275. If we subtract it, we will get a value as 125. So I am going to cross out the minimum value. Finally, I am having 150 as my northwest corner. If I am cancel out that column, last one is 10. The row and the column are balanced, 250 and 250. So my all the supplies and demands are become 0. Now I am going to add the total cost, that is 200 into 11 plus 50 into 13. These are taken from my allocated cells. If we multiply it, and sum of these multiplication will give you the value as 12,200. Similarly, we can find the total cost of the given problem by using a northwest method. Thank you.